Hello everyone, myself Pancham Singh. I am going to discuss second lecture in operating system, that is a storage structure. So before I am going to discuss about the storage structure, so which type of storage generally you will use in the storing the data. So there are different types of storage structure like primary memory, secondary memory, and these type of storage are generally used to store the data in the different spaces. So if I'm going to discuss about the primary memory or secondary memory, so which one is a volatile memory and which one is a non-volatile memory? So what is the impact of volatile and non-volatile? So volatile means if light is off, then your data will be lost. So in non-volatile, either your light is on or off, or you are directly shut down your system, then your data will not lose because the data is permanently stored in the secondary storage devices. So primary memory is a temporary, where data is stored in temporary manner, in which if light is you are directly going to shut down the system, or light is cut off and you are not having the backup like CPU, UPS, then what happens, your data will be lost. So in the primary memory and secondary memory, there are two different types of memory generally used for the storage of data. So if I'm going to discuss about the primary memory, so primary memory only large storage media that the CPU can access directly. So CPU can directly interact with the main memory, that is called the primary memory. So main memory is also known as the random access memory, or you can say typically volatile memory, because it will depend upon the light. If light is on or off, it depends upon your data is either in the memory or either in not in a memory. So it will affect on the light. Now move for the second point, that is the secondary storage. Secondary storage is the extension of the main memory that provides large non-volatile storage. So non-volatile storage means we are going to store the data in non-volatile manner. So in non-volatile means 1 minute. In non-volatile means data is stored permanently and cannot be removed by the light, or you cannot, it will not affect by the light. Either light is on or off, and your data will be stored permanently. So this is called the non-volatile. And first memory, that is main memory, is called the volatile memory. So these two important memories generally used for the operating system for running the program. So now move for the third point, that is hard disk. So what is the hard disk basically? So rigid metal or glass platter covered with the magnetic recording material. So it will store large amount of data. And hard disk has the track and the sectors. So basically hard disk is divided into two parts. One is the track and second is the sector. So sector is the smallest area where you are storing the data in the hard disk, and track is the circular track where data is stored in the form of the small tracks, sectors. So small was the group of sectors, they are making a track. So the next point is that disk controllers. So who will control the disk basically? So disk controller determine the logical interaction between the device and the computer. So this controller is controlling the disk through which we can control your information. Either you are interacting the data from the disk to the main memory, or disk to the hard disk. So solid state disk faster than the hard disk. So solid SSD, that is called SSD storage is faster than the hard disk, and that is non-volatile. So various technologies nowadays, they are using the SSD techniques. They are storing the data, large amount of data in the SSD, and the speed of the SSD is compared to faster than the hard disk. Storage hierarchy. If we are going to discuss about the storage hierarchy, so there are three important components that will be affected by the storage hierarchy. The first component is called the speed, second component is called the cost, and third is the volatility. So these are the three components, they are affected by the storage and speed. So if you are going to increasing the size of the storage, your speed is going to decrease. If you are going to decrease your size of the storage, your speed will be fast. So it will depend upon the capacity of the storage or size of the storage. Now next storing device or you can say जो storing memory, that is called the caching. So caching is copying information into faster storage system. Main memory can be viewed as a cache for the secondary storage. So cache is a faster storage device where you are going to store the where you are going to store the data in the cache. So cache is a temporary storage where your data is locally stored in the cache and it is not permanently stored. Now next point is the device driver. So what is the device driver? For each device controller to manage input output provides. So controller to manage input output provides uniform interaction between the controller and the kernel. So device controller, that is used to control the data, control the information by input output functions that is used to control the data or information. So device controller, that is used to control the data or manage the data which are given by the input output information. So this is the storage hierarchy. So we are moving from the top to bottom. If you are moving from the top to bottom, so the storage capacity is going to increase, but the storage capacity increase and speed is going to decrease. So if you are moving from the bottom to top, it means that storage capacity is going to decrease and speed is going to increase. So in this term, speed is increased. So here is speed and here capacity. So capacity is going to increase and speed is going to decrease. So this shows the hierarchy of the storage device. Now what is caching? So caching basically is an important principle performed at many levels in a computer system. So computer system basically used to store the data in a local area, that is called cache. So in a hardware, operating system and software, so caching is work in the operating system. Whenever you are going to call a program, so that program is temporarily stored in the cache. So somehow if your program is not in main memory, so you can call that particular program in the cache, or you can say search the program in particular cache and you can get the data from the cache. So it will reduce the accessing time of that particular program or pages. So now next point is information is used copied from the slower to the faster storage, temporarily. So data can be copied from slower to faster or faster to slower. So it depends upon the hierarchy, because you are moving in the both direction, from top to bottom, bottom to top. So if you're going to increase the size of the storage, speed is going to decrease. If you're going to reduce the size of the storage, the speed is going to increase. So it depends upon the storage. So faster storage, if you're going to discuss about, that is cache. So cache is the fastest storage. Check first to determine if information is there or not. So cache is basically used to cache the data, and is data is there or not, that is depend. So if it is information used directly from the cache, that is fast. If not, data copied to the cache and used there. So first, if data is there in the cache, then you can directly use the data from the cache and the speed is going to fast. And if data is not in the cache, then you will first copy the data into cache, then you can use the data. Cache is smaller than storage being cached. So cache is a smaller storage device, and that's why the speed of the cache is faster than rest of the storage capacity. But if you're going to compare the storage capacity like register, cache, main memory, secondary storage, so the speed of the cache is below the speed of the register. So register is smallest storage capacity unit that is storing the data in the form of the bits, but cache is little bit bigger storage capacity to store the data in the cache. So cache is faster. So if you are going to access any data or information that is available in the cache, then the access time of the data is going to reduce and the speed is going to increase. Now what is the DMA, direct memory access structure? So used for the high speed input output device able to transmit information at close to memory speed. So DMA is basically used to used to for high speed input output devices able to transmit information at close to memory speed. Now next point is device controller transfer block of data from buffer storage directly to the main memory. So device controller that is play a major role for picking the data from the buffer storage and directly from the buffer storage and putting the data into the main memory, and that CPU can access directly. So next and last point is the only one interrupt is generated per block. So if you're going to pick the data from the another place to the main memory, or you can say from buffer to the main memory, so at the same time you are picking at only one block of data from the that is storage to the main memory. So this is the condition of the direct memory access. So this is the diagram where how a modern computer works basically. So modern computer basically work by the CPU, and CPU is performing the operation and CPU create the threads. So if number of processes are running, so we are going to create n number of threads. So if you're going to create a program, a thread is a lightweight process. So if you're going to discuss about what is thread is a lightweight process. So this is the thread. So thread is generated and thread of execution is started in the cache, and CPU will performing the n number of input output operations. So input output request, data, interrupt. So these type of operation is performed by the CPU. And what is the DMA? DMA is directly access the data from the directly connected to the device M to the memory. So DMA is directly putting the data from the storage in the form of the block, and it will send to the main memory. So this is the main memory, data directly coming from the device to the main memory. And if you're going to discuss about the CPU and memory, so these are the instructions execution cycle is running between the CPU and the main memory. So and similarly data movement is also running in the same time between the CPU and the memory. So CPU can directly interact with the main memory, and the main memory is the memory where your program is will come inside the memory, then your program will execute. So without a program is coming into the main memory, it will not execute. So memory that is used to run your program, that is called the main memory. Computer system architecture. So a computer system is divided into different architecture, that is multiprocessor system. So multiprocessor system is basically is also known as parallel system or tightly coupled system. This is very important. You can see here. So multiprocessor system, this one multiprocessor system is also known as parallel system or tightly coupled system. What are the advantage of multiprocessor system? Increased throughput. So this is the first advantage of multiprocessor system. Now second is economy of scale. It decrease the economy. So economy will affected by the multiprocessor system. And last is increased reliability. So by using multiprocessor system, you can increase the reliability of that system. So this is the multiprocessor system. Now I am going to discuss about the types of the multiprocessor system. So multiprocessor systems are divided into two important categories. The first is the asymmetric multiprocessor, second is the symmetric multiprocessor. So this one is the first and this one is the second. So asymmetric multiprocessor, each processor is assigned a specific task, that is called the asymmetric multiprocessor. Now what is the symmetric multiprocessor? Each processor perform all tasks at the same time, that is called the symmetric multiprocessor. So this is the diagram where we are going to explain about the symmetric multiprocessor architecture. So in symmetric multiprocessor architecture, so you can see in the previous point, so each processor perform all tasks at the same time, that is called the symmetric multiprocessor. So this is a symmetric multiprocessor. So here is a CPU 0, CPU 1 and CPU 2. They are performing the task at the same time, and every CPU they are performing the task and by using the memory, and So all tasks performed by the individual CPU 0, CPU 1 and CPU 2. So these are the performance of the task by the different CPUs. Now what is the dual core design? So dual core design basically used to design as in such a way that where two or more CPU are grouped in a single block and they are using the common memory and they are performing the different tasks. So multi-chip and multi-core symmetric systems containing all chips, chassis containing multiple separate systems. So this is the dual core design. So in dual core design, there are two or more CPU. They are group of in a single manner in a single block, and they are using the common memory and they are performing the operation in the group in a dual core design. Now, what is the cluster system? So cluster system basically it is a type of system that is working together. So in cluster system is also divided into two main category, that is asymmetric clustering and symmetric clustering. So multi-processor system, but multiple systems working together behave as a cluster. So cluster can be also categorized in asymmetric and symmetric multi-process clustering system. So what is the asymmetric clustering? Has one machine in host standby, that is called the asymmetric clustering. And what is the symmetric clustering? Has multiple nodes running applications, monitoring, etc. That is called the symmetric clustering. So it will provide the high availability of services with services failure. So it will give the higher availability of the services, and where if some services are going to fail, then clustering system is going to use. Some clusters for high performance computing, they are doing the high performance computing. In the first point, applications must be written to use parallelization. So in clustering system, you are using the parallel concept, parallelization concept. So in parallelization concept, the performance of the system is increased. So that's why clustering system is more useful in the computer system. Now last one is the some have distributed block manager to avoid conflicting operations. So why distributed block manager? They are managing the blocks in such a way that there is no confliction between the processes. So this is the diagram of the clustering system. So they are interconnected to each other. So this is the storage capacity, and this is the computer, and this is the computer, and this is the computer. So computers, they are doing performing their operations, and they are interconnected by the common storage area network, that is called the SAN. So this is the common storage where all systems, they are performing their tasks in a parallel way. Operating system structure. Operating system is divided into different structures, or you can say operating system is divided in different types, like multi-programming system, time sharing, real time, and these are the types of the operating system. So multi-programming, where multiple programs are running simultaneously and CPU will giving the time. So multi-programming is also known as the job scheduling. So once job selected and run by the job scheduling. So job scheduling is a technique work in the multi-programming. What is the time sharing? So in time sharing, time sharing is a logical extension of the multi-programming. So multi-programming, time sharing is a logical extension of the multi-programming through which we are going to do the performance. So what is the process? If we are going to discuss about the process, so a program in execution, that is called the process. So what is the CPU scheduling? CPU will scheduling the jobs in such a way that your program will execute one by one. What is the swapping and why we need swapping? Swapping basically demanding when a program have the higher demand and a program is running in the main memory that has a low demand. So then what you will do? You will swap that running program to the backing store, and you will pick the program which are in backing store to the main memory. So that's why we need swapping. Swapping is required only on the basis of demand of that page which are demanding and want to run into the main memory. What is the virtual memory? So virtual memory basically used at the time of the execution when the size of the memory is not available during the execution. Then a virtual memory is automatically created to help the CPU to execute that particular program. So that is called the virtual memory. So this is the multi-layout, multi-programming architecture where job 1, job 2, job 3, job 4, they are sitting in the area that is called user area, and operating system is always sitting in the top. So main memory is divided into two blocks. One is the operating system area and second is the user area. So these are the number of jobs they are seated in the user area and they are performing their task. So operating system operations. So operating system can do the different operations like interrupt driven hardware and software. So operating system can perform different operations. Some operation can be come in the category of trap and some operation can be come in the category of interrupt. So operation can perform in the trap and interrupt form. So this is the dual mode operation. So operating system is divided into two main categories. That is there are two dual mode operation, that is kernel mode and user mode. So a mode that is used by the user, that is user mode, a mode that is used by the kernel, that is called the kernel mode. So kernel mode is the area where kernel will take the decision to executing that particular program, but a user mode is the area where user can giving the input for different files, different programs want to run. So user just give the input and that input is go inside the kernel mode, and kernel will decide either this program will execute or not on the basis of the requirement of the memory. So there are two different modes in the dual, that is called the dual mode. So how kernel mode operation will perform? So this is the user process where user is seated, and this is the kernel where kernel is seated, and both are separated by the lines. So user is performing all the tasks in the upper side, that is the user area, that is user process. So user process executing. Similarly, call system call other system is system call is going to generate return for the system call. So this is the user area. So user area is the upper side, and mod bit of the user area is 1, and similarly the mod bit of the user kernel area is 0. So this is 1 and this is 0, and that in kernel mode there is a operation. The operation is performed in the form of the mod bit 0 and mod bit 1. So in mod bit 0 there is no request, and user is inputting the request, and that request is listened by the kernel. Then your program is going to run, or your program is going to execute. So this is the mod, that is execute system call. If your request is granted or your request is applicable, then your program will start executing. So return from the system calls. So request will be coming from the user process to the kernel area, and kernel will start executing that program. So this is the user mode and kernel mode, how they are working. Thank you very much.